All right, so looking at this image, you'll notice that the first picture is showing static friction. So we have the box that's sitting at a ramp. There is a force that's pushing the box down, but friction is resisting that force. So we have a force that is acting in an opposite direction. So it results in no motion. Sliding friction. This is when you produce a force and it is sliding down the ramp, and friction is not able to resist all of the motion, so it is able to slide. Rolling friction, we have a force that it's applied to a ball or a wheel, and friction is trying to resist that rolling motion. However, the rolling can resist the friction and continue to roll. So the types of friction, we have static, that occurs between objects that aren't moving. Without it, your feet would slip out from under you or making it difficult to walk. Ice is very slippery because it has very little friction. So that first example of the force applied to the box causing no movement. Sliding friction occurs when two solid surfaces slide over each other, makes moving objects slow down and stop. For example, sliding over snow or sledding over snow. It's much weaker than static friction. Rolling friction occurs when an object rolls across a surface. It's much weaker than sliding or static. Although wheels are great for rolling and reducing friction, they wouldn't work without static friction. Fluid friction is when a solid object moves through a fluid, such as water or air. Easier to overcome than sliding friction. Air resistance is an example of fluid friction. So a fluid is a substance that can flow and take the shape of its container. Again, air resistance is a friction-like force that opposes motion of objects that move through the air. Really depends on the speed, the size, the shape of the object. All right, we have a couple learning checks. So learning check number 1, according to Newton's third law of motion, what happens when one object exerts a force on a second object? So according to this law, the second object exerts a force on the first that is equal in strength and opposite in direction. Number 2, the momentum of an object is a product of its A, B, C, or D. So even from the video we should have learned this. From the notes today you should have learned this. The answer is B. An object's momentum is the product of its mass times its velocity. When two objects collide, what happens to their momentum? The answer, according to the law of conservation of momentum, if the objects in a collision exert forces on each other, their total momentum does not change, even when momentum is transferred from one object to another. So I explained this in one of our discussion questions that we had. If you have a car crash and the car comes to a stop, well, it went from changing from kinetic energy to thermal energy to light to sound energy. So it's the same thing with momentum. The law of conservation of momentum, this momentum can't just disappear. It's just going to change forms. All right, so what we have learned in this chapter, formula-wise, we have the equation from the second law, force equals mass times acceleration, or if we're dealing with weight, it would be weight equals mass times gravity. Again, weight is a force, so these formulas are practically the same. We just put different words in the place. Newton's third law shows that the force of one object, we have an equal and opposite force of a second object. And then linear momentum, just momentum of an object in a straight line, is momentum equals mass times velocity. So use these to help do your web assignment tonight. And that concludes the podcast.